Hi everyone. So in lesson 7, we're going to explore the concept of resistance and then use something called Ohm's law to figure out how we can calculate the resistance inside a circuit. So at the very top of the lesson, we're looking at this idea of what resistance is. So it tells you here that resistance is the property of a substance that causes it to reduce electric current. So as it sounds like, it is a property that resists the flow of electrons, thus reducing current in a circuit. So it says you can think of the resistance of a material as a measure of how much it slows down the flow of electrons. So if we look at the picture here, for instance, you have a ball and then you have these pegs. The ball, as it comes down the ramp, is going to run into these pegs. So the pegs are resisting the path of the ball. And I've given you a thought question here. It says, examine the picture, which displays an analogy for electrical resistance. How could this model be modified to represent a material with lower resistance? So think about, if I wanted less resistance on this ramp, what would I need to do? And hopefully you'll get the idea that the more of these pegs that you remove, the easier it will be for that ball to flow down the ramp. And that's the idea there. So the less resistance, the easier it is for electrons to flow, the more current there is in a circuit. So down here, we're looking at what resistors actually look like. So these are common examples of resistors in circuits, but even a light bulb itself, copper wires that are being used in the circuit will also resist the flow of electrons. So really a lot of the components of a circuit actually cause some resistance to circuits, but these are specific resistors that can be added. Before we get into calculations, I want you to look at these 4 factors that actually impact the resistance of a circuit. The first factor that can impact the resistance in a circuit is the material that the wires are made out of. So we've talked about this many times, that metals are examples of good conductors. And so the better the material is at conducting current or electricity, the less resistance it's going to have. So it says silver has the least resistance, but is very expensive. Most conducting wires are made from copper. So try to fill in this blank down here. Better conductors, such as copper, have blank resistance. The second factor is temperature. So as the temperature of the wire increases, its resistance increases and conductivity decreases. So there's more resistance as you increase temperature. You might think that doesn't sound right, because you might think if we increase temperature, it would increase the speed of electrons and so they would flow faster. But the faster the electrons and atoms move, the more they actually collide into each other. And so because they'd be colliding into each other more, that's going to create more resistance. So as we increase temperature, we also get an increase in the resistance in the circuit. The third factor is the length of the wire. Longer wires offer more resistance. So that should make sense. The longer the wire, the longer the path for the electrons to travel, and thus the more resistance there is in that circuit. And then your last one here is cross-sectional area or thickness. So wider wires offer less resistance than thinner wires. And that should make sense, because the wider the wire, the less those electrons are going to actually run into each other, the more room they have to flow. So less resistance overall. So use these ideas here to help you fill in those blanks. Then we get really to the meat and bones of this lesson, which is looking at how to calculate resistance. And to use that, we use this property called Ohm's law. And so Ohm's law is written very similar to other equations that we've used. And in this case, we're using R for resistance and 2 letters that we've seen in previous lessons, V for potential difference and I for current. So Ohm's law is resistance is equal to potential difference divided by the current. I've also rearranged the equations here for you. So if you were solving here for potential difference, it is I times R, or current times resistance. And if you wanted to solve for current, you have potential difference over resistance. Okay. Be able to use these kind of triangles. This is what you would get on a test as your formula. Before we get into calculations, I'll just click on this PhET simulation. That'll help us get a visual of what this actually looks like when we set up a circuit. Okay, so here you can see our equation. Right now it's arranged as potential difference is equal to current multiplied by resistance. So we have a simple circuit here. Here is your wire, and you can see electrons inside there. And we have 3 batteries for an overall voltage of 4.5. And so we can see that here. So if I start off by increasing the voltage, so let's increase it maybe to 6. Okay. You can see the effect that it had on the current. So as I increase, let's do it again, come back down. 4.5. As I increase the voltage, I'm increasing the current as well. Okay. The resistance here will stay the same because that is remaining constant in this equation. Now, if I increase the resistance, look at the effect on the current. So the more resistance, the less the electrons are able to flow, and so the smaller the current would be. If I decrease the resistance, current increases because there's more electrons that are able to flow. And that's the whole idea that we're looking at here. Okay, so let's get into some sample calculations using those formulas. Again, I would like you to use guess method as you work through these answers, just to make sure that you're showing all your steps, including your units as you go through. So example 1 says a space heater is plugged into a 120 volt wall socket with 3 amps of current running through it. What is the resistance of the space heater? So always start off by underlining your given information. So we have 120 volts, which hopefully you can identify as the voltage or potential difference, and 3 amps of current, which is the current. And again, we use I to represent that. And we are being asked for the resistance. So let's start it off. G, our potential difference is 120 volts. Okay. And current is equal to 3 amps. Our unknown is our resistance. And our equation for resistance, so if we were looking at here, if we wanted to solve for R, you can see that would be V divided by I. So V divided by I. Okay, I'll do the solving over here. So now we're just going to plug in our numbers. So V was 120 volts. And we're going to divide it by the current, which is 3 amps. 120 divided by 3 is 40. And when we have volts divided by amps, we get a unit known as ohms. I forgot to mention that up here. Ohm's law, one of the reasons called that is because we use the ohm, the unit of ohms, to represent the resistance. And that is kind of like this horseshoe symbol right there. So that's what an ohm looks like. Okay, and then your last step is your sentence. Therefore, the resistance of the space heater is 40 ohms. All right, so I'd like you to try number 2 and number 3 on your own. When you finish that, there are more practice problems for you to try. You do not have to do all of these, but I want you to do enough until you feel comfortable with the material there. Okay, I will post answers for you to check, but make sure you're showing your work using guess method as you work through these problems. If you have any questions, post in our Teams chat. Thanks.